Hi everyone. Today we'll be presenting on Augmentation Residency, an immersive live-work HCI R&D model. So recent advancements in wearable tech, extended reality, BCI, and generative AI have brought visions of human augmentation to the forefront of our collective imaginations. Simultaneously, large-scale access to computers and the internet, as well as the rise of open-source software and hardware movements with facilities like Fab Labs, and the emergence of programmable wearables, sets the stage for individuals to be able to develop augmentations for themselves. We were a group of student engineers and artists tinkering with these technological augmentations, and we were curious about what these emerging capabilities meant for human identity and experience. And one of the key questions that came up in our work was, as HCI developers, we have these larger visions of technology transforming human potential, but why don't we, in our daily lives, use many of the futuristic technologies that we idealize? And so we wanted to investigate what it means to live with augmentation. Beyond technological augmentation, we conceptualize many different processes, from personal practices to social systems, as augmentations in the process of living. Augmentation is, to us, taking what we were given and creating new, from our physical bodies to our personalities to our stories. And at the core of this notion is the interplay between being programmed by our nature and being free to design our own destinies.
We believe that living with augmentation could be best achieved through an immersive environment that continuously shapes, cross-pollinates, and reiterates your craft. We drew inspiration from residencies in the art world that promoted transdisciplinary innovation and skill building, as well as from universities and research institutions that engage people in HCI research and development. Combining the best of these worlds, we designed the 2023 Human Augmentation Residency, a 10-week-long, fully immersive and all-expenses-paid program in which 8 artists, engineers, and researchers lived and worked together to build technologies that enhance human capabilities and experiences. 2 months prior to the start of the program, we began the ideation process of what it meant to live with augmentation. This led us to define the objectives of self-experimentation and human-centered and transdisciplinary design practices. Having the idea defined, we began the organization and setup of the program. This included the fundraising process and hardware resource management. Simultaneously, we reviewed applications for residency fellows and residency mentors and processed logistical tasks such as housing and food management. After a 2-month-long preparation process, we started the 10-week-long program through which we had to iteratively manage the resources, develop projects, and build community. We concluded the residency program with a final showcase of the projects and insights gained throughout the residency at the end of 2.5 months.
Moving on to our methods, we employed 4 key human-centered design methodologies. The first was low-tech self-experimentation to define project directions. We explored a hyper-personal, problem-focused, technology-last approach in which low-tech self-experimentation was used to identify project directions that were personally relevant and meaningful to each developer. The second was user research via semi-structured interviews and public visits to coffee spaces or other hacker spaces to demonstrate and test our technology. We also integrated creative practices such as writing, movement, acting, and play as low-tech augmentations of human behavior that could be enhanced and guided by technology. These practices inspired new ideas, informed development, and in some projects even became integral parts of the final project. Lastly, we followed a methodology of Ready, Fire, Aim, in which hardware projects focus on rapid prototyping and iterative testing in daily life. This enabled a faster understanding of user experiences, adaptation to user needs, and refinement of project goals based on emerging insights from self-experimentation.
The residency culminated into a demo day in which we shared all of our work. First being a haptic ring. The haptic ring empowered users to have a new sense through vibration. The ring translated magnetometer data into patterns that could be felt on your finger to help with orientation. The imagination engine was inspired by the Dream Diffusion paper, so we fine-tuned a stable diffusion model to generate abstract art based on suggestive EEG signals. Enact was an application that addressed interpersonal issues with acting and AI to target peer-to-peer counseling. It was a web app that people used to practice difficult conversations and help with emotional intelligence. Game Changer was an interactive narrative-based game in which players used Fluxus-inspired experiments to change themselves. It blended interactive storytelling with psychology and offered a unique journey to self-discovery. The empathy machine read somebody's EMG values and translated them to EMS values on another person. So it simulated a mirror touch synesthesia and fostered a shared experience through physical sensation. iHunch tackled bad posture with both high and low-tech solutions. It used elastic tape to electronic feedback and tried to hack a healthy lifestyle in a seamless way. Immersive was a final project that used AR to visualize people's biosignals. We map these biosignals in your visual field to help synthesize and synchronize heartbeats. And finally, we created a zine to share our discussions during the residency about the connection between philosophy and technology, and how augmentation not only enhances our abilities, but changes our perception of transhuman futures.
The Augmentation Residency exposed us to a variety of challenges and learnings. The first was choosing what to work on. We faced difficulties choosing between the human-first approach that prioritizes direct utility to a person and the tech-first approach. Also, agreeing on a user group for each project was challenging and should be done in advance. Second was balancing structure and improvisation. Basically, the question between structured R&D and artistic exploration. Rapid prototyping and a little bets approach proved very useful to us. Thirdly, work-life integration. When living and co-working together, personal and professional lines are easily blurred and managing boundaries can become challenging. We realized the importance of privacy and off-time. Fourth, experimenting in real time. Self-experimenting on topics of human behavior and interpersonal relationships can be emotionally intense and exhaustive. We recommend clearly defining the experimental context when running self-experiments. And finally, finding dissonance and meaning in our work. During the residency, we were forced to face any dissonance between our theoretical values in work and the values we enact in our real lives. We also experienced a contrast between an enchantment of techno-futures and the sometimes dull realities of developing it. However, we also found the residency to be a holistic experience, conducive to personal growth and our understanding of a more human-centered development of technology. We are actively integrating these learnings into a new residency format in 2024, giving participants the flexibility to separate life and workspaces and predefining project directions and questions in advance.
And so ultimately, this residency represented an experimental sandbox for some of our idealistic visions about our relationship with technology, work, and life. We hope that the experiences we've shared from this R&D model will be useful to future researchers, students, and organizers.